Chapter 8, Section 3, Example 4. Well, it's a little more relatable probably as a student. They're talking about student loans. And, I know you can read these. The methodology that they use is very good, but sometimes we have to explain how they approach that. And I really get worried about students that are trying to memorize techniques. Like, hey, well, this is a such and such, I just need to memorize, or I look at an example and try to memorize what they did on a different example, because it only takes just a little change in something to really change the order of things and how you need to apply our strategies. So, key things again I go through all the time is that, well, we're going to try to write equations. So we're going to translate these word problems into equations, and if I can get two equations with two variables, I have a methodology to solve this thing. And sometimes when they go through the familiarization stuff, it looks like they're doing something else, and I will point that out as we go through this. But let's look at this example 4. It says Rainey students' loans totaled $9,600 or $9,600. Part was a plus loan made at 7.9% interest. Now, remember what percent means. It just means hundreds. If we want to convert that to a number, we divide it by 100, and that's all percent means is hundreds. And the rest of the Stafford loan is made of a 6.8% interest. Now, after 1 year, Rainey's loans accumulate an interest of $702.30. Now, what is the original amount of each loan? Now, kind of the approach that I go to, and I'm going to go to their method that they talk about in the book, which is really good because you may not remember how to calculate interest and what happens with that. You need to make sure that if we simplified this thing and I just said, well, if I had this plus loan for a certain amount of money and it was 7.9 interest annually, which means at the end of the year you'll pay that amount of interest over, it's the charge you get for using their money. Well, you got to be clear that you understand that portion or you're going to be pretty lost in the interest problem. So that's where they go first. Where I would go to is, well, let's define the variables. I look at the question and it says, what is the original amount of each loan? Well, each loan means I have a plus loan and a Stafford loan. So I'd probably define the variables to be P for plus and S for Stanford. Well, so now I have two loans that are for a certain amount of money, and I know that they must add up to 9,600. I can write that equation right away and say P plus S equals 9,600. Because they tell you if you put these two loans together that you borrowed the money, it would be $9,600. I might start there because usually that's the easier equation to pull out of this, is that simple addition. We usually have some kind of total that we can, once we define our variables, we can do that. So, and they're going to do this too, and I'm going to go through the way the book goes through this, because it is a very good idea to start where they are, but don't get confused that they're saying, hey, I'm going to do this differently. It looks like we're just doing guess and check. What they really want to do is say, they say we begin with a guess. And then if we said if there's $3,000 was borrowed at 7.9% and 6,600 was borrowed at 6.8%, well, first thing I'd say, they kind of pick some numbers that already fit one of the conditions, which is that they add up to $9,600. So they're really guessing and checking here. But the key part of this guessing is say, well, let's make sure I know how to get the amount of interest paid on the $3,000 loan that has a 7.9% interest on it. And that's what they go through. You'd say, well, how would I get that interest? Well, I'd take the translation of that percent into a number, which percent means hundreds, so it'd be 0.079 or 7.9 divided by 100 times 3,000. So I'd end up with this $237 of interest on the $3,000 loan. Also, I would then take the lower interest rate on the higher loan amount, and which would be 0.068 times 6,600, and I get $448.80. Now, if I added those two things together, those two interest amounts, right, the dollar amounts for those interests, I'd get $685.80. Now, this whole guess and check thing, what you're really looking for is what operations occurred, how did I calculate these things, and remember the process that you go through. And I think most of you, when you break it down with some actual numbers, probably can do this exercise. And you could continue to guess and check, and you could do that several times, and probably eventually you might get lucky and hit right on the amount where it adds up to what they say the total interest is for this problem, $702.30. Well, this one's not right? So our guess is wrong, but by checking the guess, it makes us really familiar with the problem. What are the operations involved? I multiply these things together, then I add them together, and I end up with the total interest paid. So it's not a bad place to start. And then they go into translation. They say, well, let's let P be the amount of PLUS loan, kind of what I said before, and S be the amount of Stafford loan, and they start organizing this into a table because there's some multiple step stuff in here, and we want to make sure we got that. And these tables end up to have a pretty similar pattern to them. To practice with these tables is a very good idea. Also, they bring in, hey, I need to know how to get principal, rate, and time to equal interest right here. And that, by doing that example, if you got stuck and you say, I don't know what you're supposed to do to calculate the interest on a loan that I do know the amount of, then you need to do some research and figure that out. Now, by them giving this example in the book, they're going to expect you to know this information about principal times rate times time equals interest. Well, so again, that's what's really good about how they familiarize. If you don't understand that part, you are in trouble. You're not going to be able to get that second equation. But the first equation, again, once I define the variables, that should be easy to write. I need to take the amount of loan for the PLUS portion that I loaned and the Stafford, add them together. They need to add up to $9,600. Then they list the interest rates for the PLUS and then for the Stafford. The time is 1 year. That's the part that kind of throws you on this. You don't think about this total formula because it's an annual interest rate and the year is 1 year. So it's easy to miss that. And they could have complicated this problem by putting multiple years in here too. But we would still have enough information to solve this with the system. Well, what did you do to get the interest rate? If you did get that, well, I took that amount, which they said, well, let's throw $3,000 at it. You took it times this number for the interest rate of 7.9, 0.079 times that 3,000. Well, I don't know what it is, so I'm going to put the variable there, P. This algebraic expression right here represents the interest that you would pay on this loan for 1 year. And then the Stafford would be 0.068 times the variable S instead of the $6,600 that we played with right there when we were guessing and checking. And what do those need to add up to? The total interest paid for both loans, which is $702.30. So we end up with this equation. We need to add these two interests together to get this total interest of $702.30. Well, now I have my two equations, and I can do that. Now they do some strategy here too, and which is you want to use every strategy possible to make things easier if you can remember to do those things. And it's really just applying the same principles in different ways when necessary. And they end up with, so we got this decimal equation, we got this real simple equation, And what they do is clear decimals first. And I would recommend that, especially if you're going to go down and do elimination. Now this, like the last example, is a very good candidate for substitution too, because this is real easy to solve for either P or S on this equation. But they decide, and I'm happy they do, because it brings in some other strategies, that I'm going to use elimination. And again, whether I use substitution or elimination, remember the goal is I have two equations with two variables. I want to get one equation with one variable, and I can solve that and get a number equal to that variable. And then I can use substitution again and get my ordered pair, in a sense, or my other part of this question that I need to answer. So they clear decimals. And again, I talk a lot about understanding fractions. Can be such a huge asset if you really understand decimals, just because they really are fractions. This is 79 thousandths, and this is 68 thousandths, and this is 702 and 30 hundredths, or 300 thousandths if I want to go there, if I want it to be thousandths. Well, how do I clear that? I multiply both sides by 1,000, or I move the decimal place 3 places to the right, because the decimal system works very easily with powers of 10. 10 to the 2 power, in this case 10 to the 3rd power, 1,000. We'll move the decimal place 3 places. So I end up with this equivalent equation that has no decimals or no fractions in it. Now I have two equations with no fractions. Probably a good place to be, especially if you're going to use elimination, because I need to manipulate one of these equations to get it to be one of the terms in this to be additive inverses of each other. So when I add these things together, I get rid of or make 0 times one of these variables. And again, the result is I end up with a 1 variable equation, so I can solve it and get a number equal to that. So they decide to, and you could do this other ways, but they decide to let's make it manipulate this equation. So this first term, the p term, with the variable p, will be the additive inverse of the other equation, p term, right? So it would be, these are additive inverses. Well, how you do that, because this is 1p, it's very easy to say, well, let's take it times a negative 79. Make sure you distribute. You have to take it times both sides. That's the multiplication principle. You can't just take it times the part that you want to change. So I have to distribute it times both sides, so I end up with a negative 79p plus a negative 79s equals a negative 758,400. I think you need a calculator, right? These are the parts where calculators make sense to me. When you're dealing with fractions and trying to change them to decimals, you're probably just asking for ways to not get accurate answers. But in this case, so I do that. This adds to 0. So I end up with this new equation of 11s equals a negative 56,100, which I do in a calculator. And then I end up with s equals 5,100. Now what does that mean again? This is easy. You kind of get drilled down into process of how we're doing this and forget what S means. S means the amount of money I borrowed for the Stafford loan is 5,100. So I can put that back into that simple addition equation, which says, hey, both of these loan amounts need to add up to $9,600. So that's what they do. They put S in for, now they go to substitution. They put 5,100 in for the S. So you get P plus 5,100 equals 9,600. So P equals 4,500. And I can check it right there. And that's what they do really. They're saying, well, let's check this really against the original word problem. It says the total amount borrowed, is $4,500 plus 5,100, according to what I just figured out. Does that add up to the total amount that they said in the word problem? Yes, it does, 9,600. So now I have two numbers, really, a value for my S and a value for my P, that make the first equation true. Again, remember that we need solutions are for the equations have to work for both of them to be a solution to this system. So then we check to make sure that it actually makes the other part of the more difficult one equation to get, which was to take the interest times the um, dollar amounts, right? And um, and see if that works, right? So that's what they're doing in here. They put in the 4,500 for the plus loan, and they take it times 7.9% for 1 year, which would end up being $335.50, and 5,100 times the 6.8% for 1 year, you end up with $346.80. If you add those two things together, do you get 702? In this case, you do. So that process again is really the same. You know, the numbers get a little more difficult. I use some strategies to get rid of decimals, but I still have to deal with decimals and percents. You know, you still need to remember what those mean. And then also you got to remember to answer the question. What did they ask? They want to know what each loan value was, which is the plus loan is 4,500. So you need to answer that question. And the Stafford loan is 5,100. You know, stop there before this another tip they're going to give us for the next example.